Hi science students, welcome to part 2 of your atom notes. Our essential question today is what is an atom and how do we make a diagram of it? Make sure you've taken a minute to set up your notes like this. Alright, now that everything's all set up, let's get started. Everything in white boxes is something you're going to write, and make sure if I'm going too fast that you pause if you need to. So first off, how do we describe the elements? One thing that we use is called an element symbol. It's one or two letters that represent the name of an element. The first letter of this symbol is always capitalized. So, what are the symbols for these elements? Well, let's find them. Okay, hydrogen. We're looking for hydrogen. Oh, there it is. Hydrogen is an H. All right, what about helium? Oops. Helium. Oh, there. Helium is He. All right, pause this and go ahead and try to find carbon for me. All right, hope you found it. Carbon is a C. Okay, now you might be guessing. These are going to get a little trickier. So now we have to find sodium. And not everything on the periodic table has the letters that are like its name. So you might think sodium is going to be S, but that's actually sulfur. Sodium is right here, it's Na. Same thing with iron. You might think it's going to be I, but that's actually iodine. Iron is right here, Fe. Okay, so these are element symbols. So now we're going to talk about what does that mean. On the periodic table, the tile contains a lot of information. You should draw this tile on the left side of your notes and label the parts. Element name is potassium. Atomic number is the number of protons, 19. Element symbol for potassium is K. Seems weird, but it's probably based off of Latin. And here, this is what we're going to talk about now. Okay, so make sure you've drawn this and labeled it. That little thing at the bottom is called the atomic weight. Okay, and now you might notice it's 39.098. That's because it's an average. So what happens really is that we take the average of all the different isotopes of potassium, and that is what you're seeing here on the periodic table. So some isotopes are heavier, some are lighter, and that's why this is an average. Now we're going to use this to find different things about the element, and we need to do something to it to make sure we can use it. We need to make it the atomic mass number. Okay, so the total number of protons and neutrons in the nucleus of an atom is called the atomic mass number. This is not an average, so it's always going to be a whole number. So what we need to do is we need to look at this and we need to round this to the nearest whole number. Well, this is closest to 39, and so potassium's atomic mass number is 39 atomic mass units. That's what AMU stands for. So now let's see, how do we use that number? Well, first off, potassium has protons, neutrons, and electrons, and we can find them all out from this square on the periodic table. Protons are equal to the atomic number, which is 19. So potassium has 19 protons. Neutrons are mass minus protons. Well, our mass, we just talked about rounding that to 39 minus protons gives us 20 neutrons. So you're going to notice they're not always the same protons and neutrons, but in an atom, the electrons are always the same as the protons. So we have 19 electrons, okay? This works for any element, anything on the periodic table. You can go through this process to find protons, neutrons, and electrons, okay? So you know protons and neutrons are in the nucleus, but where are the electrons? They're hanging out in the electron cloud, okay? This is what you need to write. Electrons fill energy levels within the electron cloud, okay? It looks something like this. Now, we know it's more of a cloud, but it's really hard to draw that. So one thing that we do is we draw it as a Bohr model, which is our best approximation of that electron cloud. So on your notebook, make sure you have these circles drawn and you need to label how many electrons go on each circle. The first one can have 2. The second one can have 8. The third one can have 18. and the fourth one can have 32. So this first energy level outside of the nucleus can have 2 electrons. It's small, it doesn't have very many. The next one can have 8, a little bigger. The next one can have 18, even bigger. And the next one can have 32, very big. All right, so let's practice this. What does this actually mean? What does it look like? So we're going to practice this with lithium, okay? Now we're going to do the same process as we did before. Its protons are its atomic number. For lithium, that is 3. Its neutrons are its mass minus the number of protons. 6.94 rounds to 7. 7 minus the number of protons gives us 4 neutrons. And the electrons are the same as the protons. That's going to be 3. So now when we have that information, now we can draw a Bohr diagram for lithium. So again, the difference here is that really these are all kind of floating around in the electron cloud, but we want to draw them, and so that's why we use this kind of diagram. We need 3 protons in the nucleus. I know these are my protons because they have a plus sign, positive protons. I need 4 neutrons in the nucleus. I know these are neutrons because they have a 0 or a circle, meaning no charge, neutral. And I need my electrons in my electron cloud. 2 can go on the first energy level or the first circle. And I have to have 2 before I put any on the next one. And I have to have the next one full before I go outside of that. So you want to fill from the inside circle to the outside. And since I only need 3, that is my Bohr diagram for lithium. All right, finish off your notes with your summary and have a great day.